So the first one is 1-bit EAS, that is electronic article surveillance. So it have an storage capacity is only 1 bit, either 0 or 1 is possible. Its function is used just for theft prevention or presence detection. That means that tag exists or not. So that is the functions of 1-bit EAS. Okay. For example, clothing stores and libraries to prevent shoplifting. So this is the perfect example of electronic article surveillance, right? The second one is surface acoustic wave, that is SAW. This kind of device having storage capacity is limited because it's usually fixed code like tens of bits. Its function is use acoustic waves instead of silicon chips. It provides unique ID but not rewritable memory. For example, in harsh environment like aerospace and defense, because they can withstand high radiations and then temperature. So that is an SAR devices. Then comes to an state machine and microprocessor. The first one is state machines. It have an storage capacity, it's very low because it's just enough to encode predefined states like event flags. Its function is works like a logic circuit because it tracks the conditions or states instead of storing flexible data. For example, access control system, sensor with simple state reporting. So these are all the example of state machine tags. Then comes to a microprocessor based tags. They having the storage capacity in high in the form of few kilobytes up to megabytes. So its function is includes equipped with a microprocessor plus memory. It supports encryption, computation and rewritable storage. For example, using smart cards, e-passports, secure banking and government IDs. So I have to conclude that topic in RFID ranges from very simple storage, that means 1 bit, to powerful microprocessor tags with MB storage and strong processing. This is most important topic in RFID. It's beyond the singulation and anti-collision procedures of RFID. So in RFID system, when multiple tags are present in the reader's interrogation, so they may all try to respond at the same time, right? So this leads to collisions, meaning the reader cannot understand any of the responses. So it can be categorized in singulation and anti-collision. The first one is singulation. Here, the process of identifying one tag at a time from a group of tags. Second thing is anti-collision. The set of methods used to avoid or resolve collisions so that reader can read multiple tags reliably. So there are mainly two categories of anti-collision protocol that can be named as Alvoha based protocol and then tree based protocol. The first one is slotted Alvoha method. Here the Alvoha protocol comes from computer networking and is adapted for RFID. So it works on the idea that tags transmit only in defined time slots. It reducing the chance of collisions, right? A flowchart of slotted alvoha. So the main idea is how RFID tags and reader interact to avoid collisions and ensure singulation using slotted alvoha method. So here the diagram flows, the tag enters into the field, which means it moves to the ready state, right? In this state, the tag is waiting for a command from the reader. The second thing is reader sends request. The reader sends a request command, which means REQ command, which means any tags present, please prepare to respond in time slots. Third thing is waiting and slot selection. Here, tag enters the waiting state. So, each tag randomly selects a time slot. It can be noted here as T is equal to my underscore slot. So, from the frame, it can be announced by the reader. So, when the chosen slot arrives, the tag transitions to the sending state. Here, the sending state, the tag transmits its ID in a chosen slot. Now, three outcomes are possible here. It may be no response. Maybe an empty slot is there, which means reader gets nothing. Okay. Second possible is collision. Maybe two or more tags choose the same slot. So, reader cannot decode. Okay. So, third possible is successful read, which means only one tag is transmitted. So, reader captures the tag ID. So, if it comes under collision handling in the sense, which means if a collision happens, so the reader detects it and wait. Then reader sends a new request to restart the process. And tag then collidated will again pick any other random slot in next round. If the reader is successfully received the tag data means it sends a select command to the tag. That tag moves into the selected state. Now it will not respond again in future frames because it preventing the duplicate reads. Okay. Then comes to an dormant. Dormant in the sense sleep mode. Okay. So if the tag is not selected or it is instructed to stop, it enters dormant, which means sleep mode, which means timeout state. So, this conserves energy and prevents interference with the ongoing singulation process. So, here is the overall cycle. I have to conclude that tag enters into the field as ready state. Reader sends the request. It comes under tag wait and choose slots. Tag sends in their slots if its collision is possible. Reader resolves while the successful tag is selected. Remaining tags retry until all are singulated. So, finally, this diagram illustrates the slotted alvoha tag state mission. So, from reader's side, it just sends a request, waits and detects the collisions or success and it clears the response. From tag side, it's ready to wait to select a random slot and sending that data and selected or dormant. So this ensures that all tags are eventually read one by one without a permanent collision. So this is an adaptive binary tree protocol. So it states it's an deterministic anti-collision method. It is a systematically queries the tags to avoid repeated collisions. So it works, it's based on reader sends a query as prefix, for example 0 or 1. That tag whose ID starts with that prefix that can be responded. If only one tag responds, the reader successfully identify it. If multiple tag responds, which means that can be identified as collision, that reader splits into the group further, adds another bit to the prefix like 00 or 01 and 10 or 11. So queries each subgroup separately. If no tag responds, which means it comes in idle, that branch is ignored. So this process is continuous until all tags are singulated. That means identified.